Okay. Okay. Welcome all of you. Nice to Okay. I hope my voice is audible to all of you. Yeah. I think now my voice will be audible to all of you. Okay. So today we'll be talking about what is TensorFlow model optimization. Okay. So if you want to know about this, like I've done something here, like it is search. In the description, I have given you a link. Okay. This is that link. I'll be opening this website and I'll make you understand the code, what is meaning and all those things. This is a basic example. This is TensorFlow model optimization, optimize machine learning models. It is offers a toolkit for optimizing machine learning models for execution and deployment in mobiles and IoTs embedded devices. Okay, because there we have a limited amount of RAM and memory available, and machine learning models take a lot of RAM, graphic power, and all those things. It takes a lot of things. So we will just we compress these models, we optimize them, and we then embed them into our embedded devices, and therefore machine learning models then can be done implemented on edge devices and cloud devices. Okay, so if you want to understand, let's go on to the guide. Uh, Take another time. Okay. Okay. So this is that. Yeah. So after that, you should see that TensorFlow model optimization. I think inference efficiency is the target we are looking here. We are basically focusing on inference efficiency. We have to increase that. It is a critical concern as because of less memory latency and all those utilizations are a lot and can't be handled by edge devices or very minute cloud devices. And cloud devices today have a lot of high price. They are very high priced devices. Okay, particularly like in mobile devices and edge devices like Arduino, Spark Edge, and all those edge devices, chips, and they are a good AI machine, but they also are limited. They have less RAM, low RAM, uh, constrained amount of memory in order to compute power. So model optimization is useful for reducing the latency. Okay, if we reduce the latency, then we will save at the cost of inference. Then deploying the models, reducing the payload size, the amount of size as we compress these models. Then enabling the hardware restricted operations. Okay, then other things are optimization. There are some techniques for optimizing. The area of model optimization involves a lot of techniques like quantization, sparsity and pruning, clustering, collaborative uh, optimization. We will look at first our sparsity. Okay, weight pruning. Sorry, we will use weight pruning first. Okay, so if you want to get started here, you can choose some TensorFlow lead. These are some tutorials on that. What to do. Okay, optimize further. You can here it is given about what to do about create clustering. Very available tools are given. Documentation is really good. As I told in my previous videos, the documentation is really good. You should understand the documentation. Okay, so install. If you want to install TensorFlow model, simply install pip install user upgrade TensorFlow model optimization. Now here it is simply given that a stable build will be like this. But you need to understand about API compatibility. It's a very important thing, actually. Because like API compatibility is the thing uh, like in my laptop, I have installed TensorFlow 2.5.1, which is not the latest version, but it is workable because it is more stable than 2.6.0. It is also stable. Okay, but I have very much dependencies working due to my environment size. Okay, so uh, just see about the API compatibility. Compatible release versions you should use about TensorFlow model. Okay, let's go on to weight pruning. What is weight pruning? Okay, weight pruning is first of all a basic first thing to know is weight pruning is a method of model optimization. This document. Okay, magnitude based weight pruning actually it gradually zeroes out all the model weights. Just uh, zeroes all the model weights to achieve model sparsity. Okay, now let us understand what is model sparsity. What is model sparsity? Sparse modeling is rapidly developing area of interest. This here, this is model here. Yeah. Sparsity refers to a matrix of numbers that include many zeros of values that will not significantly impact the calculation. Okay, matrix sparsity, we need to achieve matrix sparsity because like it is a very simple thing. Like weight pruning is simply that your matrix, like your weight values will just become zero and it will achieve model sparsity. Model sparsity will be that your model weights or your matrix which contains many zero values, but it will not significantly decrease your efficiency or impact your calculation. We will see that example right now. Okay. It is a very great example if you just understand. Now, you need to only understand this much that the techniques bring improvements via model compression. This technique is basically for more compressing your model. Okay. Uh, then this technique has been used for speech recognition, text to speech, and all those APIs. We are using weight pruning as a TensorFlow model optimization technique for deploying the machine learning models on edge devices. Okay. They include very good results, very good or very uh, moderate results about image classification, like the inception model. Non sparse accuracy is 78%. The sparse accuracy is 78.0%. Okay, and the sparsity was 50% sparsity. This much thing. Okay, it didn't affect at all. 0.01. And WileNet. WileNet is a very good model. If you know what I mean, image classification models, ResNet, WileNet. These are for video and image classification top models, convolution neural networks, and all those things. With the weights of ImageNet based dataset based weights. If you want to import, you not did do a series like thing for that too, to use transfer learning, how to use transfer learning to import models like that. Okay, if you want to like inception model, the mobile net, I will make a video about what to do about these inception mobile net. What are these models? Okay, what are their advantages and disadvantages? Explain all those things. Okay. Now there is a simple example, like to train a CNN model on the MS hand recognition with pruning. Okay, now we will see pruning. Now I have this is the example actually pruning with keras. This example. Okay. Now in this example, a lot of stuff I will explain each and everything here. I have created actually my own Jupyter notebook here. It is exactly the same. I will explain the code, what it does and what it does not. Okay. First of all, we import some modules like template file, OS, and TensorFlow and NumPy at important. Then we import keras from TensorFlow, and then we load an extension of TensorBoard. TensorBoard actually does what is like here we are. I have created a Google Colab notebook also. I will share this Google Colab notebook. You know what? I will work on this Google Colab. We got Jupyter notebook. I will just download and give you the link. But TensorBoard, I'm having a big problem about the TensorBoard version, so I will just use weight pruning Google Colab notebook. Okay. So first of all, what we need to do is we have loaded extension. I don't think you can view this or not. Okay, I will increase a little bit. Yeah, I think you may be able to understand. See this now. Okay. So first of all, we'll simply load. Okay. I will just I will restart the runtime. Okay. So that we can view this what it is doing. I've changed the runtime to factory reset. I will just change the run. I have changed the runtime type to GPU. Okay. So first of all, let us import temp file of OS, TensorFlow, NumPy, and TensorFlow import class, and then we load the TensorBoard extension here. Okay. So shift enter to run it. If you don't want to if you don't want this notebook, I will explain this notebook. You can also do is that you can go here, you can view the source on GitHub, you can download this whole Jupyter notebook, and you can even run it on the Google Colab. But I am doing this because I will be coding along with it and will be explaining because actually it is for my benefit that uh, it is for your and my benefit. I will give you a type of tip here because like, if you want to understand a thing to like add like code with it, okay, code and understand. It will give you a lot more things like you will get some errors, you will not get some errors, then you will try to solve those errors and all those things. It will be beneficial for you. Okay, so enough to chat. Let's go to train model. Okay, uh, we are training a model in this without the pruning part. Simple CNN based image classification. Okay, image classification we will import NIST from Keras datasets. Then we will split the data into training images and labels and test images and labels. Using ns.load data, we have done this a lot more time. Then we normalize the pixels using this function, floor of division. Then we define the model architecture. The model architecture is simple. First, we use the input layer for the images to be inputted with the input shape of the sizes. The 28 by 28 images were there. So after that, we reshape them to a 3D image, 2D, 2D, and 1. Then we use a convolution with the convolution neural network with a 12 filter and a kernel size of 2 by 3. So it and we use activation function as a ReLU. Then we use max pooling. We use max pooling on every image of a pool size of 2 by 2. Then we flatten the image and then we use a dense layer to print out, or sorry, output the model's output. Okay. Then what we do is we define some laws, operations, some optimization, what to do. Okay. So for that we use model.compile optimizer Adam. We will be using Adam optimizer. Then we will be using loss as a sparse categorical cross entropy. Categorical cross entropy, here you can see this. Sparse categorical cross entropy is actually a very good loss function because for like we need to use classification. We can also use binary cross entropy because but here we are dealing with pixels and the classification. So we will use sparse categorical cross entropy because different sets of pixels and all this. Then we will fit the model using train images and train labels, and a validation split of 0.51 is simply that 10% of the training images will be set for validation. We will use 10% of that training images size. 10% of training images will be set for validation, and it will validate itself. Like model.fit, and we will run for this for 5 epochs. This is a simple training function. Here on this, you can see that it will first of all it is simply running. It will first download the image. It is running the first epoch, and here you can see it's calculated the loss of 0.32, validation loss of 0.14, and accuracy of 0.95. Okay, this is the validation accuracy, the final accuracy of the first epoch. This runs for 5 epochs. Okay, then after that you can also see about callbacks, but that is mainly about that is not, we simply need to understand about training a model. Okay, no callbacks and all those things. Actually, if you want to understand about callbacks, you can see another way. I will make another video about callback functions. But you need to understand here that callbacks here in Keras or in TensorFlow, callbacks are embedded in this. Okay, so we bought the final accuracy is 98%. We can print it out. What we need to do is evaluate the test accuracy, and we'll be saving this model. So how to save the model? Okay, if baseline accuracy model.evaluate, we will be using model.evaluate test images and test labels in Word. Okay, we will print this model accuracy. After that, we'll make a temporary file of .h5. H5 is the extension of saved Keras model. Okay. After that, we just save the model and we do not include the optimizer. And if we run this, it saves our model. Okay. After that, I have installed here installed TensorFlow model of I think yeah, TensorFlow model. Okay, it is already here. So after that, we will be using TensorFlow model optimization. We will use a thing called prune low magnitude. Okay, we want to know this. Okay. Let us go to it. Yeah, we will be applying the prune to the whole model and see the model summary. Okay, in this example, I will start with a 50% zeros in weights and end with 80% sparsity, and we will see the changes. Okay. So first of all, what we needed is we imported TensorFlow model optimization and shortening it as TF-MOT. Then we used a concept called low magnitude pruning. Okay, prune low magnitude from sparsity model. We import errors and then from prune magnitude function. After that, we define some variables like batch size, epochs, and validation split. After that, we define some more functions about number of images, what are the number of images, and stuff. Then we define the pruning parameters for our model. Okay, the pruning schedule will be a polynomial decay. A polynomial decay. The polynomial decay is, if you want to see this polynomial decay, uh, let us see it. Okay, here it is. It is a scheduler, polynomial decay, a learning rate scheduler. It is a learning rate scheduler. It commonly observed monotonically decreasing learning rate. Okay, it it is basically a scheduler which changes our learning rate. There are many schedulers like if you want to understand here, go to af.garage.optimizers. Optimizers, here we are, and then we have schedules. We have a lot of schedules, polynomial decay, learning rate schedule, piecewise constant decay, cosine decay. There you have a lot of schedulers. Okay. So after that, we use this model for we fit our model with tuning parameters. Okay. So I think that's it. I will make this video further a lot. You can run this. I will make a future video again. I can live and extend it.